Welcome to the film room, everybody. Today's explainer is a full-on championship game film review. We are looking at the Cambridge Mathematics 9709 tape, and specifically, we're hacking the examiner's defensive strategies, their marking rubrics for 3.1 algebra. If you're aiming for the very top of the league tables this exam season, you are in the exact right place. We're going to break down this tape, look at what the examiners are doing, and show you how to beat their defense to deliver a true masterclass. Let's get right to work.
Listen to this pregame scouting report straight from a senior examiner. They said, the difference between a B and an A star in mathematics often comes down to how well you understand 3.1 algebra, polynomial division, factor theorem, remainder theorem. Think about that. The stakes are incredibly high here. Mastering this specific multi-stage topic isn't just another practice drill. It is the ultimate grade differentiator on game day. It completely separates the students who just survived the paper from those who completely dominate it. Here is our tactical game plan for today. 1. The A-star difference. 2. Core principles and connections. 3. The method mark strategy. 4. Execution and critical analysis. And 5. Top 3 examiner traps. Let's get to it.
Starting off with Section 1, the A-star difference.
Earning top marks requires a massive halftime adjustment in your mindset. The equation is simple. Analytical depth is strictly greater than superficial breadth. Let's look at two hypothetical players on our squad, Alex and Sam. Sam is our fast attacker, right? Rushing down the field just trying to guess the final number by heart, superficial breadth. But the Cambridge assessment defense eats that up. You need to play like Alex, heavy on the defense, focusing on deep, logical, structured reasoning over just knowing a few formulas. The examiners aren't just looking for the final score. They want to see the depth of your analysis on the board.
Moving right into Section 2, core principles and connections.
Let's break down the tape on the foundational theory. The architecture of 3.1 algebra rests on 3 massive pillars. First, precise definitions. You have to know that dividing a polynomial by x minus a means the remainder is literally just f of a. Second, causal relationships. Understanding why one mathematical move necessitates the next on the field. Third, syllabus integration. These 3 are the non-negotiable building blocks of any A-star response. If your execution doesn't clearly show these, the examiners are just going to block your shot at top marks.
And here is a massive tip pulled straight from the principal examiner reports. Cross-topic connections equal significantly higher marks. When you're running a 3.1 algebra play, examiners absolutely love it when you show how it integrates with other zones of the syllabus. Connect a polynomial division problem to graphical roots or calculus foundations, and you're signaling that you see the whole field, the entire mathematical ecosystem, not just one isolated play.
All right, on to Section 3, the method mark strategy.
Okay, blow the whistle, timeout. Real quick, if you want to stay at the top of the league table this exam season, subscribe to Ace the Exams at Ace the Exams and enable all notifications right now. All right, time in. Let's talk about the method mark strategy. This is your playbook for maximizing points when the math gets messy. It means earning points by demonstrating a systematic, analytical process and clear working regardless of the final numerical answer. I'll say it again, regardless of the final numerical answer. The defense actively rewards your procedural framework, proper headings, standard formatting, correct terminology. Even if our fast attacker Sam fumbles the arithmetic at the goal line, a flawless framework saves the grade with method marks.
To guarantee those method marks, you need to run this 5-step standard sequence. Think of this as an interactive drill. Step 1. Deconstruct the question. Don't just start running, break the defense apart. Step 2. Extract relevant data. Pull exactly what you need for your theorems. Step 3. Select your analytical framework. Are we using the factor theorem or remainder theorem here? Step 4. Execute with clear notation. No sloppy handwriting, no skipped lines. Step 5. Present with proper terminology. This systematic progression is what the examiners called professional skills in their rubrics.
Let's push into Section 4, execution and critical analysis.
So, how do you critically evaluate a complex problem live on paper? You absolutely need to internalize the deconstruct, solve, evaluate rhythm. First, break the problem into logical steps. Second, solve systematically, using the framework we just drew up. But the real magic happens here. Check for reasonableness. Look at the board. Does your remainder actually make sense given the divisor? Finally, make justified recommendations based on your math. This rhythm is your ultimate defense against unforced errors. It secures every available point by proving your logic is completely sound.
This rhythm perfectly sets up the final evaluation phase. Let's say you hit a roadblock trying to counter an intricate prompt.
You need to identify limitations in the data, explicitly state any assumptions you've made, and consider alternative interpretations. It's like evaluating the quality of your own game film. Clearly defining the effect of your assumptions on your conclusions is exactly what cements those highest-tier critical analysis marks.
And finally, Section 5, Top 3 Examiner Traps.
Lean in and listen closely to this scouting report, because these are the exact spots where highly intelligent players needlessly fumble and hemorrhage their marks. There are exactly 3 recurring, critical penalties highlighted in the examiner reports. Avoid these, and your path to the championship, the A-star, is wide open.
Let's play Spot the Penalty. Here they are. Trap 1. Forgetting proper format. Skipping logical steps or writing calculations all over the margins without a clear progression. Trap 2. Failing to check presentation. Slobby annotations or missing standard mathematical terminology. Trap 3. Providing generic, contextless answers. Listen, losing easy marks to formatting is a tragic, unforced error. But trap number 3 is the absolute deadliest penalty of all.
Look at this side-by-side comparison. A generic answer gets 0 marks, while a context-specific answer scores full marks. The classic mistake our player Sam makes is doing the math perfectly, but giving a final statement that isn't specific to the prompt. If the play is calculating physical dimensions using polynomials, your answer must reflect that physical reality, not just be some abstract variable floating in space. Context is king.
Before we head back to the locker room, I have a game day preparation challenge for you to lock this all in. What is your mnemonic for polynomial division, factor, and remainder? Take the first letters, P, D, F, R, and create a memory hack right now. Maybe perfectly done formulas rule, or please don't forget remainders. Create one that sticks. When you sit down for that exam, write it at the top of your paper to anchor your mindset. You now have the examiner's playbook. So I'll leave you with this. Next time you run a polynomial play, are you actually building analytical depth, or are you just creating an illusion of competence by memorizing steps? The answer dictates your final grade. To make sure you secure that A-star, subscribe to Ace the Exams at Ace the Exams, click the notification bell, and leave a comment below with your current tier and your goal grade. Thanks for watching this explainer, and I'll see you on the field.